Hello, and welcome to day 7 of learning leetcode from chatgpt. So it started. So in the last lesson, my computer crashed. OBS crashed. So I'll carry on with explaining this solution. So this solution uses binary search and divide and conquer techniques to find the median of two sorted arrays efficiently. Here's a detailed breakdown of each part of the code. So given two sorted arrays, nums1 and nums2, the goal is to find the median of the combined array without explicitly merging them. This needs to be done in O log min n time complexity, where m and n are the lengths of nums1 and 2. So ensure nums1 is a shorted array. Random search, we assume nums1 is always the small array. This ensures that we're dividing the small array, making the binary search range smaller and thus faster. Now x is the length of nums1. Y is the length of nums2. Left and right are the bounds for binary search on nums1. We search for the correct partition. So binary search for the correct partition. So partition X is the midpoint of nums1 in the current binary search range. Partition Y is calculated based on partition X. So that the left side of the partition elements before partition X and partition Y contains half of the total elements when both arrays are combined. Okay, this ensures both partitions have roughly the same number of elements on each side. So then we're going to set the partition bounds. So max x, min x. Okay, so if partition is 0, oh, I've never actually seen this syntax. Well, I saw it yesterday, last video, So we're going to set it as negative infinity if partition x equals 0. Otherwise, it's just going to be the last one of... No, it's just going to be the one before the partition of the first nums1. Calculate the median and adjust the binary range. So right equals partition x minus 1, left equals partition plus 1. Okay, so the algorithm swaps to ensure the additional setup is x y1. So for the first iteration, partition x equals 1, partition y equals 1. So max x equals 1, min x equals 3, max y equals 2, min y equals minus infinity. Check max x is less than or equal to min y, and max y is less than or equal to min x, which holds true since x plus y mod 2 is not equal to 0. We're going to return the max of max x and max y, which is 2. Thus the median is 2. So I'm just going, what lesson was this they gave us? Okay, lesson 10 we need now. How many days? Okay. So please give me lesson 10. So, linked list basics. I'm not too good at linked lists, so let's go. Well, they're not too hard, they're just... I don't have much experience with them in Python, because I don't know really much about Python's pointer structure. How do you... So in this lesson, you will learn the fundamentals of linked lists, including how to create, traverse, and manipulate nodes in a list. Linked lists are in a linear data structure where each element or node points to the next element in the sequence. They're particularly useful for dynamic data manipulation, since the elements don't need to be stored contiguously in memory. So singly linked list, each node has a value and a pointer to the next node. A doubly linked list, each node has a value and pointers to both the next and previous nodes. Common operations: insertion, adding a node in the beginning, and and sorry about that. So insertion, adding a node at the beginning, middle, or end. Deletion, removing nodes, which can be more efficient than arrays. And traversal, going through the list to access or print elements. So, for example, reverse a linked list. So, reversing a linked list is a classic problem where you modify the pointers of each node so that they point backward instead of forward. So, let's go through the process step by step. So, first we initialize a previous pointer to none and a current pointer to the head of the first node of the list. Iterate through this. So, for each node, temporarily store the next node, reversing the current nodes pointed to the point to the previous. Then so we're going to for each node temporarily store the next node and reverse the current pointer to point to the previous. Then we're going to move the previous and current one step forward. So we're going to update the head. So once the list is fully reversed, previous will be at the new head. So here's an example solution in Python for reversing a single linked list. So we can initializer, so I'm passing constructor self.val because val self.next equals next. We initialize it with 0 and none at the minute. So reverse the list, we have the head, which is the first element. So previous equals none and current equals head. So whilst it's not null, we do next node equals current.next, current.next equals previous, and then we can do previous equals current. So next node equals current.next, yeah, and then current. So the next one is the previous one. Hold on a minute.
Doing a good job, Robert.
Okay, and okay, so we have the next node is current.next, and then current.next is equal to the previous one. And we're setting. Let me think about this. So say we have a linked list. So we have two here. So the next node equals current.next. Current.next equals the previous one, so maybe equal none. And then the previous is equal to current. So that will now equal like what this one is, and then the current equals the next node. So we're incrementing them. So instead of so these last two lines are just incrementing them, and then we just get the next one, and then the current dot next. I see. Not okay. And then current dot next equals previous. So we're just reversing the pointer instead of this way to be like that. So in this example, we keep track of the prev and current pointers. Current dot next is redirected to prev, effectively reversing the direction of the link. The process continues until we reach the end of the list and prev becomes new head. So reverse the linked list, which just gave us. So where we have, so it's just we set as none and the current one. Then the last two lines we're just incrementing them by one, and then we're going to do next. So current next was it called? So next node equals current.next, and then current.next equals previous because we're just reversing. Instead of current.next pointing to the one in front, it will be the one behind. Okay, merge two sorted lists. So problem given two sorted lists, merge them into a single sorted list. Okay. Let's have a go of this. So I'm just going to put maybe. So I'll go to Godbolt. Okay. Let's copy the merge two sorted list problem. So to merge two sorted lists, we'd have to keep, instead of keep it on. Oh, we don't need. Do we need to know? We don't actually need to. So we could do it as a single linked list, I think, because we don't need to keep track of the other one. Oh, it's just crashed. Hopefully OBS is OBS still running? I think it is. Nice. I don't know. Godboy's been pretty slow today. Or is there an XSS attack? Oh, this is the neural network that I was asked ChatGPT to make. Okay, so if I go to Python. Okay, so let's create a node. So class node cur equals okay, I'm just gonna ask it to create. Okay, so for this assignment I need a node class like the one used in. Then I'll copy the code for it. So please give me this class. So I want to see how it's implemented. Wait, is it? Did it just give us? Oh, this is it. Head, yeah, let me see. Node 2. So I'm just gonna copy this one and then copy this, and I can always add some more. So node 3.next equals node 4. Node 4 equals this node 4. Okay, and then we'll just jumble up the order. 2 and 3. So these will be the first ones. Okay, we'll have 2. And then we'll have them 2 again. Another 2, because we're creating 2 separate lists. Okay, it's 2 nodes. Oh, they're supposed to merge 2 sorted lists. Ah, I see. So 2, 3, 4. We can do them overlapping. We do 3, 4. Oops. 3, 4, 5, 6. Okay, so then now we're going to need to loop through it. So while cur equals node 1, 1, node 1, 2 cur. For some reason my keyboard is not responding to input. There's my mouse now. Okay, there we go. 2 cur equals 2 node 1. I should have just done. You can do this in Godbot, can't you? Oh no, probably not. So 2 cur equals node 2 node 1. Yeah. So while cur and 2 cur, and then we can have that, and then we're gonna, this could work for like if they're different sizes. I'm not sure what the specification was. Too much. Okay, so they're not by design to be. So we're gonna do if not cur. We can do while and 2 cur. So we're gonna do while 2 cur r equals r dot append. We can do r at no 2 cur dot and then we can do, wait, would it be 2 cur, or would we have already done that? We can just do 2 cur equals 2 cur dot next. Okay. Actually, no, we should do this after, because otherwise it might. So then, while 2 cur aleph cur and not 2 cur, we can do while cur r dot append just cur equals cur dot next. Okay, so then we need the actual while loop. So, because this bit of code oh wait, this may not work because actually would it work? It just adds the remaining parts. Yeah, I think this will work. So, cur, if cur dot, is there a value? Yeah, cur dot val is less than 2 cur dot val. Then we're just going to do r dot append so it's going to be sorted, so it's going to be cur. And then we're going to do cur equals cur dot next, as we've just read from it. Aleph cur dot val is greater than 2 cur dot val r dot append 2 cur. Oh no, it's not. Yeah, we just then cur dot to cur equals to cur dot next. I do like that, all the highlighting on Gobble. And then we can just do the else case, which will just be when they're equal. We'll just do r dot append 2 cur r dot append cur. Oh, we need to do. Okay, so I've done it as an array of nodes, not a linked list. But we can easily just convert it after. Append to cur equals to cur next. Cur equals cur next. Okay, this in theory should work, should it? So if we do output, then for I in R print I dot val, and then if we execute this, we can see that it works. Not 1 3. Let me see. So do 1 2 3 3. I don't know how we're getting another 2 again. Okay, I'm gonna ask ChatGPT up, tell it I've written this. Okay, I wrote this, and I get the following output. Please help resolve the error by making minor adjustments. So once I get like the nailed example down, it should really help me for the next coming lessons. So this year, how you set in the second link list, you're accidentally linking. Oh, am I? Go to next. Why am I doing that? So 2 codes on next. Where's it? What's it on about? From the first list. Oh. Because we're just reusing 2 node. I see. Two. Then we do 2. Hopefully this should give us the. Oh yeah, me see it does work. Just error on my part in doing that. So I'm just gonna add this to the GitHub leetcode. Maybe I make a like subdirectory. Create new file lists. Practice. Merge sorted lists. Keep my GitHub streak up, and I'll commit that, and it looks like that's it. So yeah. Oh, if I rename it. Anyway, I'll do that later. So yeah, thank you for watching, and I'll see you in the next video. Goodbye. Bye.